Today we're going to learn about systems of inequalities. A system of inequalities is a set of two or more inequalities with the same variables. So we've already graphed inequalities, and you know that when you graph an inequality, it's the same as graphing a linear equation, so a line for example. The only difference is that depending on which way the inequality is facing, you're either going to shade it in the first half or the second half of the plane, which denotes the solution to the linear inequality. So a system of inequalities is two or more inequalities that are going to be graphed. And we're going to see what their overlapping planes are. So in this first one, we have y is less than or equals to 3. A less than and equals to sign or a greater than and equals to sign is going to be denoted by a solid line. So y being equal to 3 is going to be here. So that means we're going to have a solid line at y is equal to 3. And the plane that we're going to fill in is anything below this line, since the value of y is less than 3. So we're going to shade in the half plane with blue for the first equation. The second equation is x plus y is greater than or equals to 1. Let's write this in terms of slope-intercept form. So we're going to subtract x from both sides, and we're going to get y is greater than or equals to negative x plus 1. This line has a y-intercept of 1, and its slope is negative 1. So the line is going to look something like this. Now, the value of y is greater than the value of this linear equation, so it's going to be this half plane above it. We've now graphed these two linear inequalities, and the solution is going to be the overlap of these inequalities, which is going to lie in the intersection of the two planes, which happens to be right here. So all of this region is the solution. Let's try the next one here. We have y is greater than negative 2x plus 1. Y-intercept is here, and the graph has a slope of negative 2. The inequality is a greater than sign, so it does not include the slope of the line. So it's going to be dotted. It's going to look something like this, and the value of y is going to be greater than this linear inequality, so the region is going to be around here. So we've graphed the first linear inequality and shaded the half plane to which the solution lies. Now let's do the second one. We have y is less than or equals to x plus 3. 3 lies here. The slope of x is a slope of 1, so the line is going to look something like this. Now, y is any value less than the linear inequality. The region is going to lie on this side of the half plane. In this case, the solution lies between the overlapping planes, which is this large area right here. Now what we can actually do is we can also test if a point works by plugging it to both of the equations. So let's take this point here, which is 2, 1. Let's plug it into the first equation. We're going to get 1 is greater than negative 2 times 2 plus 1. That's going to be 1 is greater than negative 4 plus 1. 1 is greater than negative 3. And this is true. So the first equation has been fulfilled. Now let's try the second one. We're going to have 1 is less than or equals to 2 plus 3, which is less than or equals to 5, which is true. So the second linear inequality is also fulfilled. So we know that the point is valid, and the solution is correct.